Greetings and welcome to my new calculus channel. My name is John Gabriel. So today I'm going to be covering propositions 3 and 4 of book 7 in Euclid's Elements. So let's begin. Now, in proposition 3, we see that Euclid shows how to find the greatest common measure or greatest common divisor of three given numbers that are not prime to one another. Okay, so obviously if they were prime, they wouldn't have a common divisor that is less than their product, right? So now if we look at the previous two, I've already explained the greatest common divisor. So in the previous video, you can see how that's done. And it's very similar because this is the same type of argument. And the easiest way to find the greatest common divisor is to factorize each of the numbers so that the product of the common factors from all these three represents the GCD, or the greatest common divisor. So that's proposition 3. And proposition 4 says any number is either part or parts of any other number, the lesser of the greater. Now this might seem pretty obvious, and people might ask, well, why does he even bother to mention it? Well, there are very good reasons, and I'll explain why in a moment. Now, this proposition might appear obvious, but the idea is that when this vita gamma measures this alpha, okay, the actual measure consists of using the equal parts of the divisor. So this line is being divided up into equal parts. And measurement in such a scheme isn't haphazard, but systematic and valid, okay? So the middle line, which is, again, this middle line here, it's the measure of these lines that Euclid is talking about, by the way. And the measure of these lines happens to be a number, okay? So the middle line is the divisor measure and is calibrated into equal parts, B, E zeta, and zeta gamma, okay? So the same idea is applied in reverse. That is, when the greater, or rather parts of the greater measures the lesser, okay? And I think we need an S here. Okay, and such parts must be equal in order to enumerate the measure. So how can you have a measure if these parts here are not equal, right? Now remember, I've told you in previous videos that if you come across something like this, you should always look for the text where it says, I say, comma, and what follows I say makes it clearer what Euclid is actually stating in the proposition. So I'm going to keep this short, and I'll carry on with the rest of the propositions, which are 4, 5, etc. Probably, which are 5, etc. tomorrow, okay? So, or another day. This is John Gabriel, and before I sign off, please click like, and if you're not already a subscriber, become a subscriber, and also visit the new math channel, to which I will place a link to in the details section, and I'll talk to you again soon. Till next time, goodbye.